For practice 18.14, we're going to look at finding the concentrations of ions left in solution after selective precipitation. Here we have a solution that's 0.085 molar in lead 2+ and 0.025 molar in silver. If selective precipitation is to be achieved using sodium chloride, what minimum concentration of sodium chloride do you need to begin to precipitate the ion that precipitates first? In other words, which of these ions is going to precipitate first? Okay, what is the concentration of each ion left in solution at the point where the second ion begins to precipitate? So what we have to do here is consider what interaction the lead and the silver are going to have with the sodium chloride. So these are cations, and so if they interact with the sodium chloride, they're going to interact with the anion. So first we need to calculate a Q for silver chloride, because the silver will interact with the chloride anion, where the Q is equal to the KSP. And the KSP for silver chloride is going to be 1.77 times 10 to minus 10. Okay. Now, the next ion was the lead, and we need to consider the Q, where it equals to the KSP for lead chloride. And lead chloride is PbCl2. So when it dissociates, it's going to form lead 2+ plus 2 Cl-. So the equation for that dissociation is the concentration of lead times the concentration of chloride squared. And we're going to set that equal to the KSP, and the KSP for lead chloride is going to be equal to 1.17 times 10 to the minus 5th. Let's go ahead and solve for the chloride concentration when Q is equal to KSP. That's the amount of sodium chloride it's going to take to precipitate those species. All right, so first we're going to calculate Q equals to silver times chlorine again. And that's going to be equal to the KSP, which is equal to, let's just write down KSP. All right, and so our KSP is 1.77 times 10 to the minus 10th. All right, and so that's going to be equal to 0.025 molar for the silver, which was given right here, times the chloride ion concentration. So we need to solve for the chloride ion concentration when the Q is equal to the KSP. So the chloride ion concentration at that point is equal to 7.1 times 10 to minus 9. Okay, and that's going to be equal to the sodium chloride concentration, because remember, sodium chloride dissociates into sodium plus chloride. Okay, so there's a 1-to-1 ratio there. So for every 1 mole of chloride, I had 1 mole of sodium chloride. So this is the concentration of sodium chloride I need to begin precipitating the silver. Okay, so the second part of this problem is to figure out at which point the lead begins to precipitate. All right, so the lead is 0.085 molar. Okay, so in our KSP is 1.17 times 10 to the minus 5th. So we have when our Q is equal to KSP, we've got lead times chloride is equal to 1.17 times 10 to the minus 5th. Okay, so that's going to be equal to 0.085 molar times chloride equals 1.17 times 10 to the minus 5th. So the chloride concentration when when lead begins to precipitate is going to be equal to 1.12 times 10 to the minus 2nd. So the silver chloride is going to precipitate first, and the sodium chloride concentration will be 7.1 times 10 to the minus 9 at that point. So let's look at B. What is the concentration of each ion left in solution at the point where the second ion begins to precipitate? So when lead chloride begins to precipitate, the chloride ion concentration is 1.2 times 10 to the minus 2. So if we plug in the chloride concentration where the lead chloride begins to precipitate, okay, we get the silver at that point is equal to, well, let's go ahead and write the whole thing out. The silver times the chloride is equal to the KSP, which is 1.77 times 10 to minus 10. Okay. And the chloride at that point is 0.012, right? So I can say 0.012 times silver times the silver concentration equals 1.77 times 10 to minus 10. So my silver ion concentration at that point is 1.5 times 10 to the minus 8. Okay. So the silver ion is 1.5 times 10 to the minus 8 at that point. And the lead, as told, is equal to 0.085 molar at that point because it's just starting to precipitate, but it didn't precipitate yet. So this is the concentration of the other two species when the second ion begins to precipitate.